Here's the solution to question 2 of homework 10. There are 7 problems to solve. Let's begin the first problem. Is correcting the definition of Y-sense stationary process. And the definition is that a stochastic process is called Y-sense stationary process if the mean of the mean equals to constant and the autocorrelation equals to the correlation of T1 minus T2. And the second problem is about independent increment process. And the definition is that we say that xt is a process with independent increments if the probability xta minus stb is smaller or equal to x1, stc minus std is smaller or equal to s2 equals to the probability of xta minus stb is smaller or equal to s1 times the probability of stc minus std is smaller than or equal to st2 for any non-overlapping intervals. And then let's begin the third problem is finding the definition of Markov process. Here's the solution. The definition of that is process xt is a Markov process if the past has no influence of the statistics of the future under the condition that the present is known. That is, for any n and t1 is larger than t2 larger than and so on, we have the probability of st1 is smaller than or equal to s1, assuming st2 equals to s2, st3 equals to s3, and so on, equals to the probability of st1 is smaller than or equal to s1, assuming st2 equals to s2. And then the normal process definition is a process is st is said to be a normal if the random variables st1, st2, and so on are generally normal for any n, any t1, t2, and so on. And that is the density function of s1, s2, and so on equals to this equation, and the parameters is this. So let's begin the fifth problem is straight sense stationary process, and the definition of that is a real stochastic process. St is stationary in straight sense if its statistics is not affected by a shift on the time axis. And so there are 5 methods to decide the process is whether the straight sense stationary process. ST is SS is straight sense stationary process if the density function meets the requirement like this one for any n, any t1, t2, and so on, and any issue. And the second method is st is straight sense stationary process, and then the density function xt equals to the density function of x. then the ST is street sense stationary process. We can get the mean of the ST equals to constant if the mean of the ST exists. And then we have the density function x1 s2 t1 t2 equals to s1 at the density function of s s1 s2 and t1 minus t2. And then we also can get the autocorrelation t1 t2 equals to the autocorrelation t1 minus t2 if the mean of s squared t exists. And then the white noise, the definition of white noise is that Vt is a zero mean white noise if the autocorrelation t1 t2 equals to this equation. And then the last problem is mean arithmetic process. Other than the definition is that ST is said to be mean arithmetic if if it meets the requirement of this equation. Note that the mean of ST must be a constant, and the mean square sense means that it meets the requirement like this one. So there are three methods to design the process whether the process is a mean arithmetic process or not. And this is the first one is it means the requirement like this equation. And if ST is WSS, this is the wide sense stationary process, and it also meets the requirement like this one, and ST is mean arithmetic. And the last one is if ST is a wide sense stationary process and requires the requirement like this one, and then the ST is mean arithmetic. That's all. Thank you.